So Richard, we've spoken about choosing a machine for our part. We've got a big block of material here. What's the next stage of the process?
Okay, so probably one of the most fundamental things to think about is work holding. So this is the billet we're going to be using. It's a rough saw cut billet, and I like to think of our part is trapped inside and we need to free it. So how are we going to do that most efficiently, the least number of setups, and how do we hold it? What I'd like to think about as well is rigidity. I keep harping on about it, but it's the most important thing. When we do our first operation, that is normally where a lot of our heavy roughing comes from. So we want to have the best grip we can on our billets. So what we've got here, we've got a base plate that's bolted down to the machine. We've then got some riser blocks, and we've got some vices. This is called a 0-point system. So there are these studs on the bottom of all these components, and they clip in. It's a really modular system. What I would suggest to anyone, there are lots of systems out there, just standardize on the one you want to choose. There's so many to choose from, do your research, but standardize on one.
And when you talk about standardizing on a work holding system, what exactly do you mean by that?
So, this, for example, wouldn't be compatible with another manufacturer's 0-point system. So have a look out there, look at what's in your budget, look at what's got the right adapters for it or the right vices. The system we use, you can even screw studs in for custom fixturing. So again, look at what's available, look at what you can afford in your budget, and just try and standardize on one, because then all your machines then, because hopefully you're going to grow and get more machines, you'll be able to change work holding between them.
Okay.
But so we've got these vices. These have actually got serrated hard jaws on them. So the serrations that you can see grip that material. The brilliant thing about this, only 3 millimeters of material is wasted with that gripping. So my tool can go all the way down to almost the top of my jaws. Please don't hit them. And then we can actually machine far more of the component in our first setup. That's the advantage of a setup like this. You can machine 80, 90, nearly 100% of your parts in one setup. That means better accuracy because you're not having to redatum the part, and also you're not wasting time redatuming. When we think about our second operation, then things can get a little bit tricky. We're thankful the part that we've got good parallel sides. If we didn't, we might have to think about custom soft jaws like the part that we've got over there.
So what's going on here then? Why are they called soft jaws?
Okay, without sounding patronising, they're soft. So the key thing here, they're soft for 2 reasons though. Soft for one reason, that I want to be able to effectively machine them. But these haven't been machined, let's talk about that in a second. So effectively machine them, but also soft so they don't damage our lovely new finished components. I mentioned machining them. These are actually 3D printed soft jaws. We're getting a lot of success at the moment trying different materials and 3D printing soft jaws. If you're 3D printing them or machining them out of aluminum or brass, really doesn't matter. The key thing is they are fit for the shape of this component only rather than generic, and they don't damage the part. That's the important things there. If you really want to up your work holding game, you can think about full custom fixturing. So this is an example where we've got 8 billets of material here doing op 10. We then flip them over and we do 8 billets of material in op 20. So in a machining cycle, you get 8 finished parts, but there's 16 on the whole bed. So it's a really interesting example of how you actually reduce your wasted time with tool changes and opening and closing the door by putting more components on a machine bed.
Got it, yeah. So I can see there's a real art to this process really, the design, the philosophy really of how you're going to hold the part.
I mean, definitely. I would probably say there is more work and effort gone into the design of this fixturing than the part it's actually making. And that's one of the beautiful things about Fusion, is that we can do all the designing in the same environment as our CAM, so you can instantly relate them back to one another, you can reference them. It really does smooth out that workflow.
Got it. So coming back to the work holding for our part that we're going to be using, I get what the vice is doing, I get what the base plate is doing. What's the deal with this riser? Why is it there? What's its purpose?
Okay, no, that's a really valid point. Because, these risers are very useful. However, don't put 10 on. The further you come off the bed, the less rigid your setup's going to be. You're going to have problems with vibration and accuracy, but we do need them. Do you remember we spoke about the 3+2 moves to access the sides?
Yep.
If we look at the column of our machine, although it is very slender, if this vice was on the table, I'm going to hit my column on the table to get to the side of this part.
Okay, yeah.
Putting those riser blocks lifts it up enough so I can access the whole of my component around the sides so we can finish as much as possible in our first setup, which is our rigid setup, and also accuracy because I haven't had to redate them. So a lot of bonuses there from not having to keep redating your parts.
Fantastic. Well, that's a lot to take in.
I know, sorry.
But I'm excited to keep going. So should we crack on and get this set up on the machine?
Yep, let's go for it. So first thing we need to do is we need to just quickly release this block. Let me grab some tools. So we need to quickly just unclamp these vices. I've only quickly, loosely nipped them up. There we go. Could you grab those gloves for me? Because you're going to be handling the material. So once you've got those, if you could just put that billet of material on the desk behind you, just so it's out of the way, we'll then strip down this system. Okay, I'd lie down flat, that's perfect. Right, now I didn't actually tighten these up, but you see we've got these screws in the sides.
Yeah.
That's what we actually use to clamp down our 0-point system. I purposefully didn't tighten those up. So if you want to take that vice off of there, do you know why I'm using two vices?
So I'm guessing it's just the size of the material, right?
Perfect. I mean, imagine that billet of material you've got there. We could put just one vice in the middle, but you're going to have so much overhang on your part then, the vibration is going to be a real concern.
Cool, and I can see these are the 0-point system that you spoke about, right?
Yeah, exactly, those are the studs. Did you notice they're on the back of our custom fixture?
Okay,
so our custom fixture can also slot onto our base plate and be machined in our machine, so really nice.
And how have they been added on?
They are just threaded into the bottom, so you create a precision hole that they locate in and then a thread as well. So the bonus here, in about 10 seconds, I can swap between a vice and a custom fixture. Really useful. Perfect. Right, now's our base plate. This is a little bit heavy, it's not sharp, but before we put this in, most important thing, cleanliness. Look at who's left that machine. We need to have a word with them. So much swarf on it. Let's clean that machine down now. We don't want any swarf. Imagine if you've got a bit of swarf on the corner of this base plate, you're going to be jacking it up and nothing's going to be square.
Yeah.
Let's get that forensically clean, and then we'll go in on our base plate.
Sounds good.
Right, Pete, so you've done an amazing job at cleaning the bed. Well done, you've passed that test. It's now time to stone the bed. This is our stone. It's got a coarse and a fine side. So what you're gonna do, you're gonna take our lubricant here, you're gonna give the bed a good old spray down, and then our bed's in quite good condition. I just want you to use the fine side and do figures of 8 across the bed for me. Brilliant, so the bed's all stoned. We've got our base plate that's cleaned as well, and we've stoned the base plate. No point stoning the bed if you don't stone the base plate as well. So do you want to go and grab that base plate and load it on? Perfect, so we've got that down now, let's bolt it down. What we've got here, we've got 4 bolts and 4 T-nuts. Really important thing, make sure your T-nuts are the right size. You don't want them pulling out through the bed, we've seen that happen before. And make sure your bolts are the right length. What I mean by that is when you have the bolts tightened down, they shouldn't be touching the base of the slot. I've seen so many times that people have been pulling down on the wrench as hard as they could, and all they've done is bottomed out the bolt on the bottom of the T-slot. What that does is just damages your T-slot and doesn't actually bring the plate down in Z. You need to make sure these are the right length. If in doubt, tighten it up and see if you can get a feeler gauge under the bolts. So that's what we've got. Why don't you take those and start bolting them in for me?
Sounds good.
Okay, so as you're tightening this down, don't go too tight because we need to get it level and square. So just nip them up so it's not going to float off the table. That's all you need to do for now.
So really I'm just holding it roughly in place, but where we can still adjust the position of the plate afterwards if we need to.
Correct. Okay, so as you're tightening these down, I just want you to gently nip them up. Don't go too hard, because we still need to be able to move this and get it nice and square.
Okay, so I basically want it to be held in place, but still with a bit of movement so that we can position it perfectly later.
Yeah, exactly. But if you do it down too tight, you won't be able to knock it into place later. Okay, so this is our setting master. We need to make sure this thing is square to the machine's axes. So X on the machine is square to the plate. Yes, this is a precision base plate. We probably could dial indicator off the sides. However, don't always trust that's the case. these center holes here are what we're locating off. So let's go off those instead.
Got it. So this thing here has been basically machined to an extremely high degree of precision, and
Yeah.
this is what we're then using to get our accuracy when we make our part.
Exactly, this is precision ground from these back studs to these faces. This is going to give us a really good location on there that we can dial this in. Okay, so do you want to place that in the middle for me in those 4 location slots? Perfect. If you want to tighten it down gently with that first, and then we'll get the torque wrench going. So can you see it says 60 Newton meters on the front there?
Yep.
That's exactly how tight we need to do this down. I can't press upon you how important it is to keep consistency with your work holding. Using a torque wrench for these kind of things is going to make your machining so much easier. You're going to have less variation, less chance of things vibrating. Don't just sit there hammering away at things and hoping for it to work. Okay, so this is the lever clock that we're going to be using to get this into position. A couple of things. We've got this magnetic base to hold it onto our spindle. We've got this articulated arm so we can move it into place. And then we've got a 2-micron lever clock. Very accurate. So you've got to make sure this is fairly within spec to start with, or else you're going to have no chance of doing it. Last thing on this, you see the actual lever at the end here. Try and make sure that's pointing perpendicular to the surface. If this is at 45 degrees to the surface, you actually get an error in what you're measuring. So try and make sure this is at 90 degrees, perpendicular to what you're measuring. It's going to make things a lot easier. So if you want, you can load that in. You turn the magnet on by going to the plus. Brilliant. You can slacken off that arm, move it into position, and now jog the machine down. Okay, so the 2 things to check for here, make sure we're actually getting a reading, so make sure the needle is touching, so the needle's not just in fresh air, and also make sure you haven't gone all the way around the travel, you're actually hitting the end stop. That's 2 really common things that we see. People are in fresh air and they think, brilliant, I'm at 0 all the way, and also they're at the end stop and they think it's perfect all the way as well. So just make sure that. So yeah, we can see here, we need a little bit of movement. We've zeroed it at one end, we go all the way to the other end. Okay.
Yeah, so I can see the dial moving as we move between, and that's basically telling me how out of alignment this edge is, right?
Yeah, to the x-axis of the machine. So if you grab that mallet, and you're literally just going to give it a good old knock on the edge here. So which way are you going first?
So if I try hitting this like that.
Yeah, that's it.
Okay, and I can see the dial moving, and that looks like that's going the right way.
Okay, perfect. So you've got it a little bit more. Do this in little steps.
Yeah.
Knock it a little bit each time.
Yeah. And I can also knock from this side, right, if I want to.
So, oh, that's looking good. So just go maybe sweep it across once more. Okay, so what, that's 2 graduates. It's only 4 microns. I mean, that's not bad. I mean, I'm going to break the bad news to you now. Because we've got a C-axis on the machine, we could have actually used the C-axis to get this dialed in, but I wanted you to go the old-fashioned way with the hammer.
There you go.
You know, it doesn't matter if you've got a fixture vise, you're doing a fixture plate, whatever you've got, which is probably what you're going to have to do to get the thing in straight.
So we could actually use this C-axis to basically spin the part rather than hitting the plate into alignment.
Yeah, this is what you might do once you get more confident on things, but this is a really important skill to learn.
Got it.
You've got that, again, you're at 4 microns out, that's more than acceptable for what we're going to be doing. Now you remember, you only gently nip down those bolts, you need to tighten them down now, and then recheck in tightening them, you haven't shifted it. So let me grab the torque wrench for you. Let me set this. We normally go down to 50 Newton meters when we tighten these down. There you go.
Thank you.
Make sure that it's on tighten mode. There we go. Perfect.
So this process we're doing now really is the key to everything else, right? If we do this properly, then when we machine later on down the line, everything we make is going to be...
Exactly. More to the point, if you get this wrong, everything else you make will be wrong.
Yeah.
It's that simple. So spend the time getting this done. Also check it periodically.
Okay, brilliant. So let's do one more check then.
Yeah, so now you've tightened them all up
Run this along.
and make sure you haven't moved it.
And that is looking really good.
Again, it's actually brought it back slightly better. You're at 2 microns now. So just tightening it can make a huge difference.
Fantastic. Okay. So our base plate is set up.
Yeah.
It is correctly aligned. Now what's the next stage?
So we're going to get that spindle up out of the way, take the clock off, take our setting master off. We've got to put both riser blocks on and both vices on. And again, torque everything down. I don't want to see any hammers hitting any Allen keys. Get everything on, torque it all down, and then we're ready to start.
Sounds good. And we don't need to do this process again of alignment because our base is aligned. Everything else is going to be aligned on top of that.
Exactly.
Thanks so much for watching. Don't forget to like, comment, subscribe, and click to watch the next video.